first terminology I just want to ask from you. Okay, first terminologies, what do you mean by language? Okay, so any opinion about you people? Can you people tell me anything about anything what you think a language is?
Something that we can communicate
Okay,
in with each other.
okay, right. Others also, what others say means, in short, Prishita is saying ki language is medium of communication, isn't it? Or it's a form of communication. Like if we want to communicate something, okay, A entity wants to communicate something to B entity. So how that A entity will tell to B entity? So in the form of some language, right? So in simple terms, you can say that language is a medium of communication. Okay, means every language will have its some set of words and some fixed rules, and using those rules, you'll try to communicate something to someone else. So in simple terms, language is a medium of communication, or language is a form of communication, and every language will have its set of rules, also called as grammar, right? And every language gives its set of words, and those all words we arrange, okay, using the grammar, and then we convey it from one entity to another entity, right? Okay, so in simple terms, what is language is clear to you. Okay, so I'm not writing everything, because in notes, whatever notes I'll provide you, don't worry, in that all these details will be there. Okay, now I'm just focusing on explanation first. So language in simple terms, you got it. So it is a form of communication, or it's a medium of communication. Okay, then talking about what is programming language. Okay, so what you can call a programming language as. Programming language is an artificial language. Languages also further you can classify as formal language and natural language. Natural language means languages which humans speak. Languages of humans, English, Hindi, Marathi, Sindhi, Gujarati, whatever. So these are the languages which humans speak. They are natural language. Okay, and those languages which are language of machines or artificial languages, they are called as formal language. Okay, formal languages are more on mathematical model, means they are described on the concept of some mathematical rules. Okay, so they are called as formal language. This concepts also you will be studying in third year engineering. You'll have one complete paper called as theory of computation. So in that you learn more detail about it. Just remember, languages are formal language, natural language. Natural language means language which humans speak, and formal languages means artificial languages or language of machine. Okay, please keep interacting. At any point, if some definition is not clear, so please ask me. The language, I hope you got it. Now coming to programming language. So obviously programming language will come under which category? Any guesses? Will it come in formal language or natural language? Formal. Clear? It cannot come in natural language category, because programming languages are not the language spoken by human. So you can say programming language is an artificial language, or programming language is a formal language. The design of programming language is more on mathematical model. I'll not go into more detail, because when you learn that appropriate papers, that time it will be more clear to you. So programming language is also a medium of communication only. Getting, as this definition of language we talked about just now, and Prishita said it's a medium of same, programming language is also a medium of communication. It is to express your algorithm to your computer. Getting? So you have written algorithm. Now algorithms, how to write it in the previous chapter we discussed. Like we can write it using simple English, or we can draw pictorial flow charts or pseudo codes. But all these things are just telling how to solve the problem. Means it is just telling you the detailed steps of problem solution. But suppose this problem you want your computer should perform it. Means computer should perform those instructions and give you the result. So now you have to express this algorithm to whom? You want to tell this algorithm to your computer so that computer will run those instructions and give you desired output. Then you have to use programming language. The programming language, what you can call as the programming language, means artificial language, and it is a medium to express algorithm to computer. Okay, so it is a medium by which we can express our algorithm to the machine. Okay, and how you're going to express it? By using programming language. And then there are different programming languages evolved. Means evolution has taken since 1950. Clear? First programming language, and then gradually many programming languages kept coming. So evolution has taken place with their benefits and their characteristics and so many things. Okay? So I hope what is programming language is clear to you. Is it? Just convey to me. So is programming language also going to give you some fixed set of words? Is it also going to give you some fixed set of rules, that is grammar, and then you have to use those words and that grammar, and then you have to construct your instructions and then give that instruction to the computer, and then computer will follow those instructions and give you the desired result. Okay, so as our natural language is also having some fixed words and then the set of rules, that is grammar, and then using that grammar we build sentences, right? The same thing here also. Here also there are some desired fixed set of what words are given, then there are some fixed set of rules, and using those rules we construct our instructions, and then those instructions we give it to the machine to perform the task. Get it? So hope the concept of programming language is clear to you. So programming language, and what is program? So you know it. Program means sequence of instructions, and those sequence of instructions which we have built using a language, that language is called as a programming language. Okay? Now these programming languages are actually classified according to the evolution only, yeah? Generation wise. The first generation language is there called as machine level language or machine language. Okay? And today also your computer understands machine language. Then we have low level language. Okay? And I am sure this all things somewhere you have read it in your schools. You have learned some computers, basic computers, or you might have done some CSIT course and all that. You have studied it. So low level language, and then we have high level language. Getting? Quickly we'll discuss about all three. Okay, we'll not go too detailed because I'm sure you know it, but still we will take a overview of all three. So first generation, second generation language, that is high level, is also called as assembly language. Okay? And we have high level, and high level languages are also further categorized. There are many more further in it. Then object oriented, procedure oriented, object oriented, non-procedural languages, so many are there. But the main three generations are machine level, low level, and high level. Okay? Now today also computer understands its own language, that is language of zeros and ones, called as a machine level. Okay? So machine level language, also called as first generation language, and it is language of zeros and ones. Means in this language, you instruct computer in some numerical codes. Means for every operation there are some numerical codes. Like if it's add operation, so they have created some code. For if it is subtract operation, some code, multiply, some code. And then those codes you have to give it to the machine in form of zeros one pattern. Now, normally in zeros, ones we cannot express. Therefore, there are other notations like octal and hexadecimal. These different notations were introduced because writing in zeros and ones become difficult for us. Okay? So, machine generation or machine level language means language of machine, and language of machine is zeros and ones. Today also computer understands only zeros and ones. It is its native language. Native language means the language which your machine understands. And in this generation, people used to write program, okay, in machine language only. Means the programmers who used to program, they used to give instruction to the computer in zeros and ones. So normally they never used to write 0 1 directly, in hexadecimal or octal notation, and then those hexadecimal notations are further converted into zeros and ones only. Getting? So only the advantage of this generation was that the response was faster. Getting? Why? Because the machine domain and the user domain. User domain means the domain in which the programmer is going to program, and the domain which machine understands. Clear? I'll consider this is the machine domain and the user domain. Okay? So domain in which programmer is going to deal is user domain, and the domain in which machine understand, that is machine domain. So there was no gap only between these two domain in that generation. Why there was no gap? Common sense, now you know it. Because programmer used to program in that language only, which your machine understand. So as programmer is only already writing code in machine domain, there was no gap only between these two domain. And as no gap, there was no need of translation, no conversion needed. Correct? And therefore, as you're giving the code only to the machine in machine language only, so it was faster, fast executed, and the response was faster. But lot of drawbacks are there, a lot of difficulties. Getting? Like you have to remember that codes for each operation. That is, for add it is 7b, for halt it is 76. Like this, numbers were supposed to be remembered, and in that case, lot of chances of entering wrong number. Sometimes the digit may go wrong. Like where I was supposed to type 4b, mistakenly I typed 5b. So the code, when you're entering it, actually this 5b means it's later going to convert into machine code only, in binary form only. 000 0101, that is 5. Then b is 11, so 0000 1011, this is 11. So ultimately it is in which form? Machine code, but we won't write this way. We will write in some other shorter notations like hexadecimal and all. But still, what I want to say is, in this, chances of typing error, typographical error, mistakenly any digit went wrong, so your code will give you wrong result. Getting? And then debugging difficult. To debug such code, machine code program, if you are told to debug, find out the mistake, okay, so you have to trace all these machine code instructions and then find out where we did mistake. Getting? So lot of difficulty in dealing with it. And as evolution was going on, higher program, bigger program to deal with machine level become difficult. So these people were not sitting idle. They introduced one concept called low level language. The next generation language came into existence. That is low level language. Now low level language means it is also called as an assembly language, and it is a language of mnemonics or symbolic opcodes. Getting? You call it as mnemonics, or we call it as symbolic opcodes. ठीक है. Opcodes means operation codes. So instead of remembering the number for each operation, that is for add it is this thing, for sub it is this thing, they said that for each operation create some symbolic words like add, sub, mult, div, load, store, jump. This way instructions were created, and then using these symbolic opcodes, or also called as mnemonic codes, programmers used to write program. So comparatively writing code directly in machine code, this is quite simple, isn't it? Comparative to writing a code in such machine language. Getting? Instead of that, writing code in this low level language is more comfortable to the programmer. The programmer got ease, but there is a gap introduced, a semantic gap. Semantic means meaning gap between these two domains. Clear? I hope you are understanding what I'm trying to say. So is a gap introduced between these two domains? Has to be. Why? Because machine is still going to understand zeros and ones only, but now you are going to deal with that symbolic codes, add and sub and mult and div, isn't it? So your program is now to be made understandable to the machine, because there is a semantic gap introduced, meaning gap. Getting? So then there was a need of a translator introduced. So there is a need of a translator which will translate this user domain to machine domain, or a translator which will fill this gap, this meaning gap, this semantic gap. So in short, as we went to the next generation, okay, benefit to the user is there. Why? Because it is more comfortable to write program in symbolic code than to write in machine code. So comfort to user has been provided, but gap is introduced, and there is a need of translation from user domain to machine domain. Getting? And as there is a time taken for translation, there will be a response delay. Here now the execution time will be little slower comparative to previous one. Clear? Okay. So as I said, this domain gap is to be filled. So advantage is कि writing code using machine is more better than writing using symbolic codes, isn't it? You will also agree कि writing a code using that symbolic code, add, sub, mul, div, those instructions, like if I want to add a equal to b plus c this way, so you'll just write like move in the register, like I have some register, in that I'll copy b, then I'll in that register I'll add c. Register is a temporary memory of your computer, so in that value of b is bought from memory. Variable b value is bought in the register, then in that register I'm adding value of c. So now in the register that addition is there, but that I have to store it in a. So again I'll write move the value of register in a, to copy the register value in a. So this way I'll write a symbolic code. So writing program using this symbolic code is far better than writing machine code. Like suppose I'm saying a move code is for b. Getting? A register code is 1. Address of b is 25 suppose. Okay? Code of add is 7d. Getting? In hexadecimal I'm writing. A register 1. Address of c is 075 suppose. So this way, if it is a machine code, I am supposed to write code in such machine instruction. Instead of that, now I am going to write in this symbolic code. So writing program in symbolic code is far better than writing in this way. Getting? And here typographical error, here mistakenly any digit goes wrong, you'll get a wrong result. Isn't it? But in this case, typing errors are less chances because you are typing it in that English words. Okay? But advantage you got it. But there is a gap, and this gap is to be filled. And to fill this gap, we need some translator, and the translator introduced over here is assembler. So the one thing what we need is an assembler. So assembler is a program, means one more program is to be created, and that program will convert your assembly program to machine code. The conversion of assembly program to machine language is done by that assembler, but assembler will take care of it. Getting? You don't bother about it. You write your code in this assembly instruction. Getting? But again here, ease we got, translation is done by the assembler. Okay. Only one drawback is that this assembly instructions or low level language is machine dependent. Machine dependent meaning that for every machine architecture, okay, your every computer architecture is different. So for every machine architecture, you have to study different assembly language. Assembly languages depends on which CPU you are having, which processor is present in it. So is it a 8085 processor, or is it a 8086, or is it a Pentium, or is it any other Motorola processor, or is it a supercomputer Spark, Ultra Spark? So for every architecture, these assembly instructions change. Like if you are learning long back 8085 processor, so its assembly language is not even more than 100 instructions. Okay, but if you study Pentium machine, so Pentium machine is having more than 350 instructions. So every architecture instructions changes. So for every new architecture, you are supposed to study this assembly language. And to overcome this problem also, that for every architecture, I am supposed to study different assembly language, they came with a concept called high level language. Getting? So high level language is the third generation language, and high level language is more of natural language. It's more of like English. So as you express anything in English, as you express your algebraic equations, okay, so in a high level language, I just want to add B to C and store, I'll just write one line code, which you have to write 3 lines code in assembly. Getting? And which will get converted into this machine code. You understanding? So high level language was introduced. Why? Because in case of low level, we are supposed to study different assembly instructions for different architecture. So why not to come with one common language? Common language means common set of instruction which will not depend on the CPU. Let your architecture be anything, the way of writing program should remain same. It should not vary from architecture to architecture, and that is high level. The high level language is more of natural language. It is more of English like, as you express anything in English. So high level language, I hope you got it. So the main advantage of high level is it is more closer towards human language, or it is more closer towards natural language like English. So as you express in English that if this is, then do this, or else do this, or do this for this much number of time, or do this till this condition doesn't satisfy. So as we speak in English, the same way you can express your instructions. Get it? But now tell me, as high level language is making programmer work more better or more easy because it's coming closer to natural, gap is still going to introduce. Don't you think? Is this gap still going to increase? Now the domain, user domain and machine domain gap is still increasing. Why? Because user is going to talk in more of English like, that is high level. That is first to be brought into low level, and then low level to machine code. So who will do it? So one more translator is introduced called compiler. Getting? So compiler is going to do what work? Compiler is also a translator, remember. But what does compiler do? Compiler will take your high level language code So compiler is one more utility, or you can say it's one more program. Okay? One more program, but for every language there is a different compiler. Okay? So what is this compiler going to do? So it will take your program written in high level language. Okay? It will check if there are any errors in it, syntax errors. If you have done any syntax error in this high level language program, then it will generate error. Getting errors. But if not, so it will convert it to low level. Many people say compiler converts to machine code. Never it is possible. This you'll realize it when I'll take first C program toolchain. When we'll compile our first C program, I'll show you each and every intermediate steps. Okay, what will happen after pre-processing? What will happen after compiling? What will happen after linking? And each step output also I'll show you. Generally in no books or many people don't show you about that tool chains, but I'll give you that each intermediate output, then you'll realize it कि compiler never directly brings machine code. Compiler will first convert it to low level, and then compiler only internally employ assembler, who will give call to assembler compiler, which will convert this low level language code, getting, to which code? Machine code. Getting? But this assembler is internally called by the compiler. So we don't come to know that really this has happened. Getting? So who is actually going to convert this low level to machine code? Assembler only. And who is going to employ assembler? Compiler internally. Getting? So compiler why is needed? I hope you got it. To translate high level code to machine. Right? But can you see that the gap introduces still more, bigger gap? So more and more ease is coming to the programmer. Programmer convenience is increasing, but gap is also increasing, and therefore the time needed for translation will increase and the response is going to delay comparative to first generation. But anyway, it is still better to program in machine. It is still better to program in high level than to write programs in MLL. And one more benefit of this high level language is in which low level language it's going to get converted, compiler will take care of. You understanding? Means that respective language makers who make it, those companies give compiler for every architecture. Means there will be a compiler for each architecture. Compiler for Windows will also there, compiler for Mac, compiler for Linux. And what these compilers do is they convert it into low level of the respective architecture. So you don't bother about which assembly language it's going to get converted. You're getting? So if suppose this compiler is running on Pentium, it will convert this high level code to Pentium assembly. And if the same compiler, okay, means that compiler of that language, if it is running on a Motorola 6800 processor, so it will convert the same program into that Motorola architecture assembly. You understanding? So respective assembly conversion, this compiler will take care of. So that benefit we get it. Clear? So I hope these three generations are clear to you. That is machine level, low level and high level. Okay? And C language, which we are going to learn, is considered to be as high level language. Getting? It is also called as middle level. Why? I'll tell you. Many books say it as a middle level, but actually it is coming under high level language category. Right? So suppose if I have written a statement A equal to B plus C. So this will be a statement in which language? A equal to B plus C. Can anyone tell me? If I have written an instruction A equal to B plus C, so this will come under category MLL, LLL or HLL. No? Pardon? Loudly.
High level language.
High level language, right? And then this statement, who will convert it into this sequence of assembly instruction? Move register B, add register C, then move that register value again in A. So who is going to translate this high level instruction A equal to B plus C in this sequence of assembly code?
Compiler.
Very good. Compiler means you are hearing me. Huh? Sure, good, very good. You people are listening to me, right? Because as it's an online mode, I'm not able to see you. Offline mode, there is eye to eye contact. So I can see your, read your faces, and then from that I can guess ki really you're understanding or no. But as you're responding means you have understood. So who is going to convert this high level code into this sequence of assembly that is in low level? Compiler. And then these sequence of assembly code are converted into sequence of machine instructions. Actually these are machine instruction, 4B 1 0 20. This is for our convenience. Ultimately that 4 is represented as binary, 0 0 1 0 0 is 4, B is 1 0 1 1. You understanding, no? Clear? So ultimately this is binary code, but instead of writing zeros one pattern, so difficult for humans, so they introduce some other notation called hexadecimal or octal. Okay, so this sequence of machine instruction, who will translate it? Yes, assembler, right? Loudly you should say. Clear? Assembler. So assembler will convert this sequence of assembly code into this machine code, and then these machine codes are given to your CPU for execution. Will CPU execute these instructions? Yes, because it is now in its native language. No? As it is in its language, it is understanding it, and therefore it can perform those instructions and give you the desired result. Clear? Okay, so concept I hope you got it, right? So programming language means what? Programming language means what? That is clear to you. And then the generation of languages, machine level, low level, high level, and whatever it is we have reached in high level generation. Then also still computer understands machine level only. Okay, though we have come into the next generation. High level is having so many benefit. It's readable, getting editing of that program is very easy. Then you can trace that program, error fixing so easy. Getting it's more closer to natural language. So expressing your algorithm using high level is more easy for the programmer. So a lot of benefits we have, but benefits are there, but the gap is increased. And as the gap is increased, the time needed for translation will be there, and therefore the response will be little slower comparative to dealing directly with machine level. Okay? So till here, if everything is clear, okay, so we can proceed further. Okay. Now, what is program that you know it? Program is sequence of instructions written using programming language. So using programming language will write some sequence of instructions, and those sequence of instructions, when your computer will perform, it will give you some desired result. So that we call it as program. Now these programs are also further classified as system program and application program. Okay? Everything systematically documented form, notes I'll give you, don't worry. Here now the main concept is understanding. So program are of two type, one is system program and one is application program. Okay? Now system program means those programs which help to develop user program. Clear? Means whatever programs user want to develop, to the entire process of developing our program, some other programs are helping us to develop it. Okay? So those are called as system program. Okay? So system program means programs which assist or programs which help in developing user program. Okay, so who all come in system program? I'll come to it. And obviously, what are application programs? Programs written by the programmer according to its requirement. Custom made program. Getting? Means whatever is the requirement, according to the requirement when we write a program, that will call it as application program. Like suppose I am telling you to write a program which will take marks from the student and it should generate and give you mark sheet of it. Okay, so that is tailor made na? According to our requirement we have written the program. Okay, or I tell you to develop a program for tic-tac-toe game. Tic-tac-toe, I hope you know, cross and circle. Okay, or write a program for snake ladder. Develop your own snake ladder game or develop your own calculator. Okay, or I'm saying develop your own clock which will tell you the system clock. So these are according to, or I'm saying write a program which will generate a pay slip of an employee. It will take number of days, basic salary, and it will calculate all earnings, deductions, and then generate a full complete pay slip for that employee. So it is an application program. So application program is programs which are tailor made or programs which are custom made or programs which are created according to user requirement or user specifications. And the programs which help in developing such application program are system program. Get it? Now, in short, I'll tell you. Okay, suppose now you have decided to write an application program, a very simple application program, accept two numbers and calculate GCD of it. It is application program. So I have to type that program. So from where I'll type it? So I'll need one program called editor. Okay, some standard editor I have to use. Getting? Like I'll use Notepad, or if you're working on Linux system, so I'll use VI editor or gedit. Clear? So many editors are there. So editor is a program which allows you to create a file, save that file, open old file, and type your code in it, right? And do standard operations like cut, copy, paste. These are the standard operations. Okay, so that is your editor. So is editor helping us to develop application program? Yes. Getting? Then tell me, once we write this application program, it will be in high level language. We have to bring it in low level. So we'll need an assembler. We'll need a compiler. Right? Then compiler will convert to low level, that low level to machine code. So I'll need assembler. Getting? Then many times it may happen that you have written one module of code, clear, means one sub program you can say, okay, and there is another sub program and something from that program you're using in this program. Means something is developed in this program and you're using it here. Okay, so while translation they are individually translated, but when you are supposed to run it, this code is to be bought here in this code, and then a single executable code is to be made. You understanding? No? When this is translated, this thing is unknown. You have just used it, and what you are using is in another program, and that is separately translated. Now here the thing which is referred from another program is to be combined with this program so that it will become a single executable code. So I'll come to it when we'll see the first C program. Okay? So that work is done by a linker. So linker combines different modules. Linker combines different machine codes to create a single executable code. Getting? And then now this single executable code is combined, but to run it you have to bring it in memory. Without coming in main memory, your program cannot run. So who is going to bring it in main memory? That is loader. Getting? And during all this thing, okay, we need to interact with the hardwares. That is, your program is on the disk. So from disk, it is to be bought in main memory. Getting? Then CPU will start running those instructions one by one. Getting? During that time, it may take some input from the keyboard. It may produce some output to the monitor. So now, are there any hardware interactions happening? And for that, we will need operating system. Getting? So all these programs are helping to run our program. So they are called as system program. Getting? So I hope you got it. Okay, how editor is helping, how compiler is helping, assembler, linker, loader, OS, how these all programs are going to help to develop our program. Getting? OS will come into picture when one hardware is to be interacted with another hardware. That is memory, keyboard memory, memory monitor. Getting? So during that time, interaction between the hardwares is not possible other than OS. Getting? OS is like your nervous system, you can say. CPU is like your brain. The actual processing calculations CPU is doing. So CPU is like a brain, but OS is like your nervous system. It does the interaction, okay, between one body part with the other body part. So exactly same. OS also plays the role of interaction between one hardware and another hardware. Okay? So I hope the programs, system program and application program is clear to you, right? So just give me confirmation accordingly. Okay? So till now, everything, whatever I told, that is clear to you? Sure? Okay? Good. So just quickly tell me what is system program, just to wind up with today's session. And then in the next session, we'll start with history of C and then first C program, all that will take. Okay? Initially, it will take time, guys. Till we don't study first C program very properly, very properly, it will take time. And once that is clear, then I'll bring you on the track and then it becomes very smooth to learn the next concepts. Okay? Okay? So tell me what is a system program and what is an application program. Is there a difference between it? System program, application program. Yes, tell me. Expecting answers from you guys. Between low level, machine level, low level, high level. That is also clear to you. Generations. Just quickly tell me what is the main drawback of low level language program? Limitations. Drawback instead of that, limitation. Can anyone quickly tell me limitations of low level language? No? You can unmute and you can tell me, you can type also. One main limitation I told about low level language program. Low level language means assembly language. Language of mnemonic instructions or language of symbolic code. So it is a language of symbolic codes, symbolic opcodes. Means for every operation there are some symbolic opcodes created. Like for addition, add, sub, mul, div, load, store, jump. This way instructions are created, and using those English words or that symbolic opcodes, symbolic operation codes, we write program. So what is the limitation in that? Obviously it is better than writing code in machine language. Writing code in machine language, comparative to that, it is better to write code in symbolic code. Right? But what is the limitation? No? Told you also. No, not a single person. Others like Rishabh, Rishita, Sahil, Sakshi. No, don't remember single. What was the main problem? I gave you also examples, like if I'm using 8085 processor, then if I go to 8086, if I go to Pentium, then if I'm going to some other architecture like 68, Motorola 6800. No, guys?
We
Rishabh?
need, we need,
Or
as
it
we
is
don't
machine
have
dependent.
One by one. I'll hear both of you. Sakshi was telling something first. Okay. Tell me.
has different systems have different architectures, so we need to know the assembly language for all that.
Yes, very good. Right? So, why you were taking so much time to answer? And Prishita, same thing, I guess.
Same.
Huh. So that is, so you were knowing it. Why you take so much time to answer? So it is for every architecture. For every architecture, there are different set of assembly instruction. We have done it, like for you, your generations. Now this syllabus is made like that. They are trying to take to more and more later technologies. But 26 years back when I did engineering, that time we used to do codes more in assembly only. I have now you'll feel funny like a Pac-Man game. It's so easy, but I did that Pac-Man game in assembly language. 8086 4000 lines code in assembly instruction. 8086 architecture. Using 8085, I created one crane, one small lift crane I created, which used to go up and down. Clear? Using 8085 assembly instructions. Getting? Now it becomes so easy in Python like language, but what she said is right, both of you. Okay, assembly language is machine dependent. For every architecture, there are different set of assembly codes, and you have to remember that. So it becomes so difficult, and that is the reason we go for high level. So is high level machine dependent, or will the instruction set remain same irrespective of the architecture? So let the architecture be anything. Will the instruction set remain same? Means I want to write a equal to b plus c. So I'll write a equal to b plus c only on every architecture.
Yeah.
Okay. But that instruction when get converted into assembly. So is the assembly different for different architecture? Though the
Yeah.
high level so bringing it into assembly is the job of compiler, right? So is the compiler concept clear to you? Compiler translates high level to low level. Assembler converts low level to machine. Then I hope the concept of that is also clear to you guys. That is system programs and application programs.